Welcome back. So this is our review for summative number 6 in Algebra 2. We're in the fall of 2019, so make sure you're looking at the right review. And this summative is going to have two older sections show up again. And the first one's going to be our radical 6.4 part 2. And we're going to have a question on there where you're going to have to know how to reverse the formula for radical to rational exponent and also be able to explain how to do the problem without a calculator. So that might be a bit of a challenge for some of you, and you are going to want to use your chart. That salmon colored chart that we gave you. So the first task is, do you know how to transfer between the two forms? So remember, when you have a radical like this, there is secretly a 2 in the index. This is called a square root. So the power for the exponent, if you're in rational exponent form, is the exponent divided by the index. So this becomes x to the 5 over 2 power. A lot of kids think there's a 1 there, but we know there's no such thing as a first root. So similarly, this one becomes b to the 1 over 4 power. Make sure your exponents are small and they're in the superscript position. So these next two questions is the opposite of that. You're going to rewrite them in radical form. So I'm going to draw a radical symbol, but I'm going to put the index of 3 in the little tiny corner here. And then we have b. The 7th power can be in the radical or it can be out of the radical. So similarly here, you're going to draw a radical symbol. This time there's a 2 in the index. If you wanted to put a 2 in the corner here, that would be totally fine. Or you could put nothing and we'll assume it's the square root. And then your base of y, you can write it to the first power. Outside of it like this, you can write no power because we assume it's the first power. This is the part that I'm a little concerned about though. Would you be able to explain to somebody how to compute this without a calculator? So your first step is to rewrite, because our brains can't really do rational exponents, but they can totally do radicals. So you're going to rewrite as a radical. So for us, that would be rewriting this as the cube root of 27. And then I would for sure put the power on the outside, because remember, we're trying to do this without the use of a calculator, and raising 27 to the 4th power without a calculator is not something I know how to do. So then our second step would be to simplify the radical and then also simplify the power. So I'm going to take my work over here. I'm going to rewrite this as, I know what the cube root of 27 is because maybe I know that in my memory, or maybe I have to use my chart, but the cube root of 27 is a 3. So this really says 3 to the 4th power. And again, on my chart or from memory, if I'm really great at these, 3 to the 4th power is an 81. So the question on the test is going to ask you to explain how would you do this. So you're going to have to write me some sentences, some words about, first I would rewrite this as a cube root, then I would, find out that the cube root of 27 is 3, and then I would raise it to the 4th power. All right, I'm going to skip around a little bit because of the sake of space. I'm going to do number 16 to the 5/2 power here. So our first step would be to rewrite as a radical. And I'm not going to write down words here, but I'll say the words. So I would rewrite this as a radical where it's the square root of 16, and we're raising this to the 5th power. But I know what the square root of 16 is. I know that that's really a 4. So this really says 4 to the 5th power. And then 4 to the 5th power is something that I would have to look on my chart for probably, of what's 1024. So these are totally, you're capable of doing them without a calculator. You just have to rewrite them as a radical first. So then we have the big Kahuna problems, right? So the square root are going to be the tricky ones. Right? These are the nasty ones that we're going to have to do a lot of simplifying. The cube root are going to be nice and easy, because I purposely made some on your test that are going to simplify all the way. So again, we're going to have our chart next to us. And we're going to write these as a broken up radical. I'm going to start with the 28. The 28 I'm going to break up into a perfect square times its leftover part. So when I look on my chart of perfect squares, I'm looking at 4, 9, 16, 25. 4 is a factor of 28. So I'm going to write this as, instead of 28, I'm going to write 4 times 7. And then for the x to the 5th power, I'm going to write that as x to the 4th times x to the 1st. And I'm breaking it up that way because remember this is a square root, so I can partially reduce x to the 5th if I break it up. the y to the fourth, I'm not going to do anything with because it's going to divide perfectly. And then z to the third power, I'm going to break that one up as well into z squared times z to the first. Okay, so what I'm going to do now is I'm going to circle things that are going to be stuck in the radical. So like the 7 and the x to the first and the z to the first. They're going to be stuck in the radical, so I'm just going to go ahead and quickly write down a radical. I'm going to write those back in the radical. But everything else gets to simplify and come out of the radical. So when I think about what happens when I simplify the square root of 4, I get a 2. And then simplify x to the fourth, I get x squared. Simplify y to the fourth, I get y squared. And then simplify z to the second, I get z. There's your final answer. So these are a little messy, and the first task is, can you break it apart? Once you can break it apart, I really want to see you guys like thinking about who comes out of the radical and who doesn't. I think if you start breaking them up that way, even if you're not using colors, I think you'll have better luck if you do some circling and underlining. Now, when I look at 4a, this is supposed to be easy, right? So my teacher told me they're going to be easy, so they should be easy. So on the cube root chart, your cube root chart is, let's see, 8, 27, 64, so on and so on and so on. So 8 is a perfect cube. So everything here is going to reduce. The cube root of 8 becomes a 2. And then the cube root of a to the 12th, so you would divide the power by the index and you get a to the 4th. And then the cube root of b to the 9th becomes b to the 3rd. And then the cube root of c to the 3rd becomes c to the 1st, which you can write a 1 or you can write nothing there and just write a c. So, easy cube root problems, not so easy square root problems. So I would definitely work on those square root problems a little more if that's what's messing with you. Factoring, oh, by the way, there will be a bonus question on that section of the test. Factoring shows up again. There's also going to be a bonus factoring question if you were already amazing at it. Write yourself a huge note, though. You need to look for the common factor first. That's the top of our flowchart, and you get to use your flowchart. And a lot of you missed some points the last time we tested because you didn't look for the common factor. So number 5a definitely has a common factor. Common factors can be variables. They can also be numbers. They can be a combination. The common factor in this problem is a 2x. And if you factor out a 2x or you undistribute a 2x from that problem, you're still left with an x minus an 8. Technically, we're factored. That's done. There's no other factoring you can do. X minus 8 doesn't factor any further. What I saw from a few people when they were doing these questions, and they did a really nice job of this, they would show me the divide by 2x underneath the problem itself, and then they were able to come up with this x minus 8 a little easier. But the important part is that you don't lose that factor of 2x. If you factored it out of the problem, it's still in front of the problem. So I'm going to do 6a now, and I'm going to look for a common factor again because my teacher made a big deal about it. Turns out this time I don't have a common factor. But what you do have is the difference of two squares. So the difference of two squares, the pattern on your flowchart says to factor it into a plus b times a minus b. So when I go to look at how I could factor this, it factors into, let's see, the square root of 9x squared would be a 3x and a 3x. And then the square root of 16 would be a 4 and a 4. And then one's going to be a positive and one's going to be a negative. As with every factoring question, I love when you guys check the arches. On the difference of two squares pattern, the arches should add up to 0 because they should cancel out. And they do. Notice there's no x's in the middle. So recognition of that pattern is really important for Algebra 2. So start recognizing it. All right, I was warned to look for common factors, so I'm looking through these terms, and there is not a common factor this time. So now I can jump into the reverse FOILing process. I'm going to start with the 12x squared, and I'm going to write down some options. It could be 3x and 4x. It could be 6x and 2x. It could be 12x and 1x, but I'm thinking I can ignore that one. So I have to just kind of start making some guesses and checks until I get it to work out. Same idea is going to happen for the back terms multiplying to a negative 3. I know the signs have to be one positive and one negative. I'm not ready to commit to where they go yet, though. But the good news is 3 is prime, so 3 and 1 is the only option. So now I have to just kind of get brave and make a guess because, you know, I don't really know. So 3 and 4, 6 and 2. If I tried 3 and 4 first, which is probably what most kids do because they're pretty close together, you'd run out of options as you check your arches and you realize it doesn't work. So because I kind of already solved this problem in my head, I'm going to start with 6x and 2x. And then I think about the placement of the 3. I would not put a 3 right here because that would have a common factor of 3 in that parenthesis. And we already said there is no common factor. So I'm going to put the 3 anywhere. It's going to be back here. And then Mrs. Meyer always does that thing where she checks the arches before she puts the signs down. So I think I'll use that little trick right now. This is a 2x. And then this arch is an 18x. And I know one of them's negative. So if I make it a negative 2x and a positive 18x, my arches will add up to positive 16x like I need. So the worst thing you can do in factoring is to just not write anything down. Like, don't be afraid that what you're about to write down is wrong, because you're going to check your arches and you're going to keep working the puzzle until it works out. It might take you a couple tries. That's okay. All right, so there will be a bonus question on factoring. It's a good one. Hopefully you guys try it. This is a new section, domain and range, and whether it's a function or not. So this one on your review is a little open-ended. It says, give an example of a set of points that is not a function. Now, 2 things I want to point out to you. All I want from you is a set of ordered pairs. I don't want a drawing. I don't want a function itself. In fact, I want not a function. So what I'm looking for is a set of ordered pairs. So I'm just going to make 3 ordered pairs just because it sounds like a good number. And if it's not a function, what you should be seeing is a repeated x value. This is that weird boys and girls thing that we talked about before, right? So if I look through my x's, the definition of a function for a set of ordered pairs would be that every x is paired with only one y. So why is this not a function? And that would be because, I don't know why I'm starting a sentence with because, but x equals 3 is paired more than once. So x equals 3 is paired with 4, it's also paired with 5, and that's why it's not a function. However, you can still give me the domain and range. The domain would be all of your x values, and the range is going to be all of your y values. But because this is a listing of ordered pairs, you're just going to list out all of your x values for me. So 3 and 2 and 3, I don't need to write the 3 twice. You're just going to write them in a little list. Don't put interval brackets or anything. That would be wrong. The only thing you could do is you could do this fancy set brackets. But don't put like parentheses or regular squared brackets. That would mean something totally different. The range would be all your y values. So 4 and -1 and 5. And you can write these in any order you want. I'm just going to write them in numerical order. So the other way for you to write this would be to use set brackets, -1, 4, 5. You don't have to get fancy though, okay? So you can either just list them out like I did, or use set brackets, but don't do anything else. All right, so now, again, it's an open-ended question, so there are many answers here. So I'm just going to come up with one. This time I want to graph a function. So as long as it passes the vertical line test, I'll write a little note to my readers here, must pass the vertical line test. There. How's that look? Is that a function? That would pass the vertical line test. So the domain, remember, reads from left to right. And the domain starts at -4. And then it goes forever to the right. My range reads from the lowest y value to the highest, so bottom to top. It's hard to write sideways on a tablet. Alright, so range reads like this. So it starts at, how low does it start? It starts at -4 again. That was coincidence. And then goes up to infinity. It's a negative right there. Cool beans. All right, many, many, many answers you get to come up with there, guys. As long as it passes the vertical line test and you can give me domain and range, you're good. So here's another example. This one's already done for you. There are ordered pairs here at the endpoints. So I'll take a variety of answers because this last one is not really like set. This is a function. They didn't ask me that though. But remember, domain reads from left to right. So the domain starts here and ends here. So for a lot of kids, because they have to write an interval notation, they'll just give their best estimate on this one. So they'll say like -4 to 4.5. I like that answer. And then range, right over here, range is the lowest y value to the highest y value. So it reads from bottom to top. So the range starts down here and then get to the very, very top here, guys. It ends up here. So I don't know, I'm going to say like -2 to 2.5. I'm estimating again. I don't know for certain if that was the right estimate, but close enough. So if that happens on the test where it's not quite perfect, I'll take a variety of answers. All right, here's another new idea for us, the absolute value function. Somewhere on this page is the absolute value function itself. So what we have to do now is remember what all these pertinent pieces are to the absolute value function. So the a value, the number that's in front of your absolute value bars, tells you whether it's opening up or whether it's been reflected, and it also tells you if you have a vertical stretch or compression. The vertex itself is located at h, k. So keeping all those things in mind, they want to know about transformations. This is a question about transformations. So your options for transformations are right or left, up or down, and then a reflection is a possibility, and then a vertical stretch or compression. I should have wrote smaller. All right, so right or left, up or down, did it reflect? Is there a vertical stretch? Is there or a vertical compression? All right, let's figure it out. So right here, this 4, this is a right 4 shift. Remember, there's a built-in negative. And then this -2 off to the side here, that is a down 2 shift. So you should be able to identify the 2 transformations based on the formula. Now this one has 3 transformations. Be careful. You've got a negative in front, so the negative is the reflection over the x-axis. If you just wrote down reflection, that's fine. If you're going on to pre-calc next year, you got to be real specific, and you got to call it reflection over the x-axis. All right, then you have a 4 in front of your function. Because the 4 is larger than 1, the 4 means that you have a vertical stretch. And then to be really thorough, I'll say of 4. If it was a number that was smaller than 1, like 1/2, 1/3, that would be a vertical compression. And then this +5 thing, that is an up 5 shift. And of course, you have a $150 machine that graphs for you. So if you're not sure, graph them. Graph the parent function and graph the new one and see if you can tell the difference. All right, so here we're going to see our vertex. Remember, there's a built-in negative, so your vertex is at -2, 3. And that graph from the earlier slide was supposed to be down here. So I'm going to pretend that I have a graph over here. And your vertex is plotted at, okay, I really wish I had a graph now, because now I got to draw it. Okay, so 1, 2, and then up 1, 2, 3. So your vertex is about here. And then in front, your a value is a -1/3. So that means you're going to travel down 1 and right 1. But you're also going to move down 1 and left 1. That's how you're going to get that absolute value shape. So down 3. So down 1, right 3 over here, and down 1, left 3 over here. Of course, if I had an actual graph, it would look better. Ooh, that's ugly. Okay, so now that I have this really ugly picture, I'm supposed to also come up with domain and range. Well, domain is an easy question, right? Because the absolute value functions go forever to the left and forever to the right, no matter what happened to them. The range might take a little bit of thinking. Remember, range is low to high, so you have to be real careful that you're doing range in the right order. It has to be low, comma, high. So for us, it starts down at negative infinity, right? It goes down forever. But the height, it stops up here, which I believe was at 3. And because it's the vertex, it's a point, so you're going to use a bracket. You should notice a connection between the k value and then either the beginning or the end of the range. They should match up. That's a good double check. And then there's one more question. We got to create the equation. Now, unfortunately, this graph's really hard to read. So first thing I want to point out to you is that you have your origin right here. So this vertex, this is the first thing that I would point out to myself. I would say, okay, where is the location of my vertex? The vertex is located at 1, 2, 3, 1, 2. So it's at the ordered pair negative 3, 2. That means your h value is negative 3 and your k value is 2. The other thing I'm going to point out to myself is because it's upside down, that the a value is negative because it's opening upside down. Now I should count my slope to figure out how far away the vertex is from one of the points on the branch, and this looks like a good point to get to. So if I get my bifocals on, it looks to me like it's moving down 1, right, I can't see that far away, is it 3? So it looks like it's moving down 1 and then right 3. I already know it's negative. All right, I think I have all the pieces of the information. So, oops, they call it f of x, not y. So my new function that I'm creating from the graph has a negative 1/3 in front, and then in the absolute value bar, it's x minus the h, so that would be minus a negative 3 would look like this, and then plus k, so plus 2. Creating the equation is kind of the synthesis, of the whole topic of absolute value functions. It's all fine and dandy to be able to graph them, but if you can create them from a graph and go both directions, then you're good. All right, that's your test. I wish everyone the best of luck. Happy homecoming week, and go Huskies!